So today I'm going to show you how to use the Runnable interface and thread safety using Synchronized. All right, so let's get to our project here. We have our project 25, Runnable Sync. It's got one package, one class. In the class, I have a main method. So in my project here, what I want to do is count money from several toll booths that are running all in different threads, right? So the cars are passing, and I'm going to have one money counter that's going to be updated, and that's going to be the shared resource throughout the threads. So I want to come over here to my package. I'm going to right click, I'm going to hit new, and I'm going to make my money counter first. So I'll call this money counter. Money counter. And the money counter will have, let's say I don't know anything about threads. So I'm just going to make this like a regular old Java object, and it's going to have the value. That's the money. And I'll do this public double get next to update the money from the threads. The threads are going to call get next as they get cars that run over the toll or run through the toll lane. The value is going to be updated with value plus 1.5. So we're going to say $1.50 per car. Then we'll return the value. And then at the end of it all, let's be able to get the total value. I'm just going to say get value. I'm going to do a regular old getter and return the value without any updates. Oh, I don't want void. I want double. There we go. And we have our money counter. So this is our shared resource. And you might be thinking, uh-oh, there's going to be problems. So if you are, you probably already know Synchronized then. Let's do a right click on the package, and let's make our runnable thread, our class that's runnable. Class, and then I'm going to call this a toll booth. Toll lane. Nobody uses booths anymore, right? Just go right on through. There we go, toll lane. And the toll lane, each toll lane is going to have a reference to the one and only money counter. So in the constructor, I'll have our money counter get passed in. I'll say this counter equals counter. All right, that's looking good. We also want this to be, we want to be able to run this as threads. So we don't want to extend the thread class because we are covering the runnable interface. This is just another way of doing threads. And let's spell implements right, and then we'll be good. Over here, this is complaining, add unimplemented methods. If you'll remember the thread, when we extended the thread class, we overrode the run. We're going to do that here too, except now we have to because we're implementing an interface. We're not extending the thread. So let's go ahead and make our cars go through. So I'm going to do a for loop, for I equals 0. We'll have 10 cars go through, I++. And let's do a printout, sysout, thread, current thread, get name. I'll say current value equals counter get next. So we're printing it as we're updating. Let's do a little bit of a pause. So we can sleep, and we'll just do a 100 millisecond pause. This is complaining because it should be complaining. Let's save that. Oh, it's not complaining yet because I have an error. Make sure you put your parentheses here if you're copying really closely. Now I'm getting an error saying, hey, surround with try catch. Sweet. There we go. Nice. Okay, so that's going to work. Let's go ahead and get it running. We're going to try one toll first. Remember, we need our money counter. We're only going to have one copy of the money counter. New money counter. And now, since we implemented the runnable interface, we can't just do a toll lane and then the dot start for the thread. We actually have to use an instance of a thread. We have to make a new instance of a thread, but pass in the toll lane object. And we've got to get a counter in here. Remember, I had a constructor for the counter. Then here, T1 start. So it's pretty similar. All right, we're gonna wait a little bit. Let's do a thread.sleep. And we had 10 cars, each waiting 100 milliseconds, so it should take a second to complete. Let's wait 1.5 seconds, so 1500 milliseconds. I will add throws to declaration, so we'll have throws interrupted. And then we'll do a printout of our value, sysout control space, total money collected, plus counter, and then that's just the get val. All right, so this is no problem here because we are not sharing the resources with more than one thread. So we got 15 bucks, that's right. Each car was $1.50. We had 10 cars, $15 was collected. Let's go ahead and add another toll lane. And we'll just make this T2. Make that T2. And we'll update this to 2.5 seconds. So everything is finished before we do our get value for our total. Yeah. Uh-oh. Look at that. $22.50. We should have got 50. Look at that, we got duplicates in here. How did that happen? Couple duplicates. That's no good. So what happened is midway through thread execution, the processor switches control, pauses the thread, and this is called preemptive scheduling. And when we were here, we're doing this get next, right? We have to do a couple operations. We have this value, we're gonna add 1.5 to the value, then we update value, then we return value. But what happens if we get to this point with a thread? So we have our value plus 1.5, thread pauses, preemptive scheduling hits, boom, the other thread comes in, but somehow completes. Now two threads have the same value. That's no bueno. You're not gonna have enough money. Your data is contaminated. So what we gotta do is we gotta make this money counter, we have to make this get next atomic. It's gotta be an all or nothing operation. So use this keyword, oh my gosh, if I can spell this right, synchronized, and that's gonna put a lock on this method. So no other thread can get in there if it's being worked on. It's an all or nothing operation. That's gonna make everything okay. That's all we need to do. It wasn't very hard. Wait till we get into like threads blocking each other. That's even harder. So look at that, 30 bucks, looking good. We did not get fired for producing bad code. Let's add another thread just to see if it works. For 3 threads, right? I have a T3 and a T3. And now I'm looking down here. I noticed these are out of order. That's okay. They're printing out of order. It's just the way the thread is printing to the screen, but you'll notice there are no duplicates, right? Everything is adding up correctly. And we'll check it even more thoroughly with 3 threads. Go ahead. Oh, you know what? I should have made that 3.5 seconds. That still works good though. 45. All right. No duplicates. We have a thread safe money counter. All right. So I will continue on in the next video, a little more about threads, and let me know if you have any problems, and good luck.